In the final problem of homework 5, we're going to examine supply-side economics. Here we're given data for hypothetical country, Krakosia. We're going to copy this data and paste it into Excel. Now I've already copied and pasted it in Excel. We're going to generate a scatter plot with the data and then answer these questions right here. So this is the tax rate in Krakosia, and this right here are the billions of dollars that are generated. To generate the scatter plot, we highlight the data. I have the tax rate in column C and the tax revenue that the tax policy generates in column D. Then I go up here to insert, and I want to pick scatter plot, just a plain one. Then I'm going to delete that right there. And then you can insert a trend line in this scatter plot by right-clicking on a data point, add trend line, make a polynomial of order 2, close. So you can see that tax revenues rise as tax rates are raised, but there is a point when the tax rate gets too high. After this tax rate, when tax rates are raised, revenues actually fall. And this relationship between a tax rate and the revenues that it generates is called the Laffer curve. It would be a curve that rises, peaks, and then falls. Because no one will pay taxes when the tax rate is 0%. No one works if the tax rate is 100%. People work more as a high tax rate is lowered, which raises tax revenue. All those statements are true, so all of the above. Next, in part B, suppose you apply regression analysis to the above data. And suppose the estimated regression equation is given by the following, which is graphed down here. Little t is the tax rate, and capital T is the tax revenue. What we're going to do is we're going to use this equation here to answer questions here. So I'm going to scroll down and paste that equation into here. I'm going to get rid of the t, get rid of the space, change that to times, insert what we call a caret, shift, and then the 6 key, because the first t is raised to the 0.5 power, and then change long dash to short dash for subtraction, and then just change that to times. Now I want to replace the t with maybe cell A, 24. I want to do the same thing with this t. So if the tax rate is 0%, zero tax is collected. If the tax rate is 10%, then $3.050 billion is collected. In part C, using this equation, suppose Krakosia sets a tax rate of 15%. We're going to substitute 0.15 into the above equation to compute the tax revenue it expects to collect. And then we'll do that for 25%, 35%, 45%, and 55%. So I'm going to go ahead and type in 15%, 25%, all the way to 55%. And then as I pull this down, tax revenue is going to change as the tax rate rises. Tax revenue. And this is little t, the tax rate. So tax revenue rises, then it falls, it continues to fall, and it continues to fall. So this is the answer to the first answer blank in part C of Cengage Now. Billions of dollars to 3 decimal places. And then 3.526 at 25%. And then at 35%, the tax revenue is 3.408. At 45%, the tax revenue is $3.114 billion. And then the tax rate of 55% is $2.703 billion. Now down here in Part D, we want to calculate how much tax revenue changed by when the tax rate was raised from 15 to 25, 25 to 35, 35 to 45, 45 to 55. So we're going to call this delta T. We can't calculate that difference in taxes, but I can calculate this difference in taxes. It's positive, so tax revenue rises when taxes are raised from 15 to 25%. But then taxes fall as we raise the rate beyond 25%. So this is copied and pasted into this first answer blank in Part D. Then these are all these declines in tax revenue are pasted here. The optimal tax rate for Krakosia would be 25%. If I drop a line straight down from this curve, it looks like the optimal tax rate is 25%. Notice that when we raise taxes from 15 to 25, revenue goes up. But once we get to the optimal tax rate of 25%, an increase in the tax rate actually lowers tax revenue. If the tax rate is currently set equal to this value, then raising tax rate raises tax revenue. That is not correct. Cutting the tax rate raises tax revenue. That is not correct. Raising the tax rate reduces tax revenue. That is true. Lowering the tax rate reduces tax revenue. That is true. So C and D are correct. If politicians want to provide the most government services without running a budget deficit, government expenditure cannot exceed the level of tax revenue at the optimal tax rate. So government expenditure cannot exceed the tax revenue at the optimal tax rate. And the tax rate must be set equal to 25%. According to supply-side economics, a high marginal tax rate or heavy regulations reduces work effort, investment and saving, retards total output because it discourages work effort, adversely affects the rate of capital formation and efficiency of its use, slows the economic growth rate. So all the above are true. Furthermore, reducing high marginal tax rate and government regulations shifts aggregate demand to the right. That is true over the long run. Shifts short-run aggregate supply to the right. Shifts long-run aggregate supply to the right. Lifts the left curve upward, grows tax revenue over the long run, allows politicians to provide more government services over the long run. Since all those are true, you choose all the above. All the above is only true if the change in policy is permanent. In Part G, you earn $81,477 working $2,000 a year, and are taxed at a rate of 10% for all income between 0 and 30,000. 25% for all income between 30,000 and 90,000, and at 35% for all income over 90,000. If you work an extra 1,000 hours a year, say in a side business, you generate an extra $133,876 in income. So in Part 1, if you only work 2,000 hours a year, we need to calculate your income taxes that you pay and your disposable income. I've already copied all these numbers into Excel. If you work 2,000 hours, you earn $81,477, and these are your tax rates that you pay. You pay 10% for your first 30,000 earned, 25% for all income earned between 30 and 90, and then 35% for all income earned over 90,000. So in scenario A, on your first $30,000 earned, you pay $3,000 in income tax. Now, since $81,477 is less than 90, I have to subtract this value from 30,000. So if I add those two values, I get the earned. So in the last $51,477 earned, you pay $12,869 in tax. So your total taxes paid are $15,869, and your disposable income is $65,608. So I'm going to copy your total taxes paid, and I'm going to copy in your disposable income. If you decide to open up a side business, which pushes your hours of work to $3,000 per year, you will pay more in taxes, and your disposable income will be higher. So on your first $30,000 earned, you pay $3,000. Since this value is bigger than 90, I can type in 60,000 here. The difference between 90,000 and 30,000. So on the next $60,000 earned, you pay $15,000 in tax. Now, since your earnings is $215,353, and you've already paid tax on the first 90, down here we subtract our total earnings and these two values. So you pay tax on the first $30,000 at 10%. You pay 25% tax on the next $60,000, and you pay 35% on the last $125,353. If I sum these three values, I get earnings for scenario B, $215,353. So I know we're doing this right. Then I multiply the $125,353 times the tax rate for all earnings over $90,000, and you pay $42,874. So total taxes paid is $61,874. Your disposable income is the difference between your earnings and the total taxes paid. So I'm going to copy $61,874 into your income taxes when you open up that additional business and work a total of $3,000 a year. And I'm going to copy in your new disposable income. Down here, working the extra 1,000 hours increases your disposable income by, so this is the increase in disposable income, $87,872. Get $87.87 per hour for that effort after tax. Suppose politicians wanting to tax the rich are able to raise the top marginal tax rate 85%. There's no difference in this problem here because we didn't make earnings in scenario A that were more than 90,000. But it does affect these numbers down here. So we're going to take this 85%, and all we're going to do is we're going to change this value here to 85%. So the only thing that really changes here is this final number, and then these numbers down here. So all the other numbers were identical. So we're just going to copy and paste them from above. So this is not changed. This is not changed. But in part 2, working the extra 3,000, the numbers have changed, haven't they? So your disposable income is now only $90,803. The income taxes you pay are a whopping $124,550. And working that extra 1,000 hours really doesn't pay off as much as it did before, right? Because your disposable income only rose by $25,195, which is only $25.20 per hour. Suppose there are 50,000 citizens of Krakosia. They are all identical, except 70% of them open a side business. The top tax rate is 35%, but only 10% open a side business if the top tax rate is 85%. At a top tax rate of 35%, the tax revenue the government collects would equal $2.404 billion. Now, how did I get that? I took the amount of taxes a person pays in scenario A, those who do not open the side business. I multiply that by 0.3. The 30% of citizens who aren't going to open the business. And then I multiplied that by the number of citizens in Krakosia. And then I added that to what? The amount of taxes the 70% of the 50,000 citizens in Krakosia would pay when they open the side business. So again, this part right here is calculating the amount of taxes the 30% of Krakosian citizens pay. And this is paying, or this is calculating the amount of taxes the entrepreneurs pay into income taxes. Then I divide the whole thing by 1 billion. So I'm going to copy that into Excel. Or I'm going to copy that into Cengage now. In this other scenario, at a top tax rate of 85%, the tax revenue the government collects would equal $1.337 billion. Now, how did I get that? This first part is the amount of tax that the 90% of 50,000 citizens pay when the top marginal tax rate is 85%. 90% of citizens will not open a side business at that high tax rate. It's just not worth it for them. So we take the amount of tax that a person would pay if they don't open a side business, multiply that by the 90% of the 50,000 citizens. This down here is the amount of tax that the entrepreneurs pay. G10 is the taxes that an entrepreneur would pay to government at the 85% top marginal tax rate. Only 10% of the 50,000 citizens open up these side businesses, which is why I multiply G10 by 0.1 and C22 to 50,000. Then I divide the sum by 1 billion. So tax revenues fall quite a bit when tax rates for the rich are raised. If Krakosia lowers its top marginal tax rate from 85 to 35%, tax revenue will rise by $1.067 trillion. And I'm going to check my work to see if I got everything right, and I should. Looks like I got everything correct.